video 4, we do not have any notes per se that I passed out in class for this, so don't freak out that you don't have notes. But these are just kind of 2 extra practice or homework problems that I will be looking at to make sure that you did these. And it would really benefit you if you tried to do these problems on your own without just watching me do the 2 examples myself. So what I want to encourage you to do is to, when you see the first and second problems, is to pause the video and try to work them out on your own if you can. Then once you get an answer, fast forward to the part where you see the final answer and see if it matches your own. If your answer and my answer are the same, then you know you did it right and you can continue on. If you notice your answer is different from my answer, that it's really different and not just probably a rounding error, then you probably want to take the 5-10 minutes to actually watch the problem being worked out. And let's say, for example, when you get to the second problem, you have no idea how to even start it. You can go ahead and watch maybe the first minute of it to see how I get it set up, and then you can pause it and try to work it out on your own, and then check your solution with my solution. So that's what I'm going to recommend for these 2 particular problems. So on to the first example. So the first homework problem said to calculate the probability of randomly selecting a point in the blue shaded region. Now, first off, some things that's not really here that we will kind of assume. Number 1, that this is a square. Both of these are by themselves half circles. The centers of both will be here and here, right in the middle of each side. And the last thing that we may assume is that randomly selecting a point will land within the square. Okay? So we're not saying, oh, we can select a point that ends up somewhere outside of here. We're not going to say that. So in this problem, there is no number, but we've done a few problems already together in class to know that you may make up your own number if you so desire to. Now that only covers one specific scenario. So if you want to challenge yourself, you should really try doing this with a variable, which is what I'm going to do. Okay? Now if you did it with a number, that's fine. Just know technically that is called an informal argument, that you are making your case informally with one scenario, not all scenarios, which would be done using a variable and therefore would be called a formal argument. So if I need to make up a number, and I said again I would do a variable, I'm going to call the length of each side 2x. And you might ask, well, why call it 2x? Well, over here, if this length is 2x, and I'm going to need to calculate the area of this half circle here, I'm going to need to know the radius, which means I'm going to have to cut this 2x in half so that this is x and this is x. That way I don't end up with any fractional pieces, and I want to try to avoid using the fractions as much as possible. So if I want to find a probability of being in the shaded region, I need to find the area of the shaded region and divide it by the area of the whole thing. Okay, so now I'm going to further define what these really meant. The shaded area, well, that's not really a specific shape that we know of. But to get this specific area here, we'd really need to find the area of the square, which is really the whole thing. Oh, crazy E. Where's my back button? There we go. And subtract away the area of the 2 half circles. 2 halves make a whole. And the whole thing, again, is the square. So this has given us now a much cleaner blueprint for what we're going to have to calculate. So the area of the whole square, okay, well that's 2x by 2x. So 2x times 2x. Then we need to subtract away 2 half circles, which I mentioned earlier is really just one big continuous circle. So the area of a circle is pi r squared, where our radius is x. So pi times x squared. All divided by the area of the square, which again is whatever 2x times 2x is. So let's simplify this up now. So 2x times 2x is going to make 4x squared minus pi x squared. I can't really do anything with that. All divided by, again, 4x squared. Now, looking at this, there are technically 3 terms at play. There's this term, there's this term, and there is this term. And what do all 3 of these things have in common that I could factor out? Well, all of them have an x squared. Oop, oop, oop. There we go. There's the squared again. So now what I could do is factor out an x squared on top, and I'd have 4 minus pi left over. And I could factor out an x squared on bottom, and that's really not factoring out, but you get the idea. Now, I've got x squared and x squared here. I may cancel these out. And you might go, well, Mr. G, hold on. You said we couldn't cancel stuff out like that if there was junk in the trunk. And there's obviously a minus sign right there. That's some junk in the trunk. Well, those are technically 2 different trunks. So this kind of represents one trunk, this the other. So I couldn't cancel out those 4s because they are in the same trunk and there is a minus sign going on there. So I may cancel out those x squareds, which is nice because now I have nothing but really numerical values here. So now if I take my calculator, and let me grab one here real quick, and in my calculator put in parentheses 4 minus pi divided by 4. This is giving me approximately 0.2146 or 21.46%. So that is my probability of landing in the one of the 2 blue shaded regions. Okay. Now if you used any other number, like even if you wanted to call the side length 2, and the radius is 1 in this case, you're going to get that same exact answer. Okay. You're just not going to have variables that will cancel out in the very end. So my method applies for any value of x. Meanwhile, if you just chose 2, you're picking a specific value. You're not picking every value. It would take you forever. And you would never finish if you were to pick any possible value for the side length of the square. So that is, and the second example. So if you guys want to pause the video, read through this, and try to set it up, that's fine. Or if you want to watch just the first little bit of this to see how it's really set up picture-wise, since they give you no picture, you can at least watch the first little bit to get a picture, and then you can pause it and see if you can work the problem out. So it says the state of Connecticut is approximated by a rectangle 100 miles by 50 miles. Hartford is approximately at the center of Connecticut, which is its capital. If a meteor hit the Earth within 200 miles of Hartford, find the probability that the meteor landed in Connecticut. So first we need to have a picture here. What's going on? Well, we have the state of Connecticut. They said it is a rectangle that is 50 by 100 miles. So we'll say there's 100 miles, there's 50 miles. And they said Hartford is right in the middle of Connecticut in that rectangle. Now, a meteor is going to hit within 200 miles of Hartford. So within 200 miles, let's make this look maybe somewhat legitimate. Make bigger, stretch it out. Let's make it a little bit bigger. Stretch it out. So we're going to say that's about 200. Okay, so here's 100. Maybe there's another 100 there to the end of the pencil. So somewhere, swing this over here. This is going to be rather difficult considering what I want to do here. Okay, we'll just do it this. So if this is Hartford and this represents out to here, this is a 200 miles. Okay, so the meteor could land, anywhere between here and here, or it could land anywhere between, what if we went up this way and then looked at this 200 miles out to here, right? That's another 200 miles. Well, it could land anywhere along there. Or what if we kept going around really, this meteor can land within 200 miles of Hartford. Well, it doesn't really specify which direction we're going in, right? So it could land in any direction 200 miles. And if I consider 200 miles in any direction, that's really given me one big circle that has a radius of 200. So, what is the probability that it lands in Connecticut? So that is our favorable region. Here's Connecticut. And it could land anywhere, even outside of here. So you can see our probability probably, no pun intended, isn't going to be too big. Because if we look at, and I tried to make this as much as possible to scale as I could, this rectangle is not that big compared to the rest of the circle. So it definitely seems like it's going to be much smaller than, say, I don't know, 20, 10% maybe. I don't really know. That's what we're going to have to calculate. So probability of landing in Connecticut, we need the area of Connecticut divided by the area of all. Now, the area of Connecticut is just 50 by 100, which is 5,000. Sorry, getting ahead of myself. And the area of all, well, remember, this is anywhere. The meteor could land anywhere in this thing, in this big O circle that has a radius of 200. So we'll have pi r squared. And so we'll have 40,000 pi. Now I could do some simplification here, or at this point I can just type it in my calculator. Okay? If you want, you could cancel up to 3 zeros here. And then the 5 and the 40, 5 can go into 40 8 times. Really, this is just 1 over 8 pi. If you want to type it in as 5,000 over 40,000 pi, one thing, you'll have to make sure in either case you put parentheses around the denominator numbers here. Otherwise, it will multiply by pi instead of dividing by pi. So 5,000 divided by parenthesis 40,000 pi in parenthesis is approximately 0.03979 if I were rounding this to 4 significant digits, which is another way of saying 3.979%. So it's actually smaller than what I was thinking. I was thinking it was maybe going to be somewhere around the 10% range, but it's a little bit less than 4% that it lands in. Okay, and that is all for this particular problem. Again, either way, either one of these here, we would have gotten the same answer. That's all.